Hello and welcome to part 51. In this video, we will continue our discussion on access modifiers. In the last video, we have seen three access modifiers which were public, private and protected. In this video, we will see how protected internal and private protected will work. As we have seen in the last video, we can use access modifier to hide or unhide types and type members in C#. So let's continue our discussion and start with our first access modifier, that is internal. Internal access modifier in C# restricts access to classes, structures and their members like field, methods and properties to within the same assembly. Means if we have marked something as internal, that will be accessible within that assembly. It cannot be accessible outside that assembly. So basically, if you have marked any member as internal, then what will happen? That member will be accessible within that assembly. They are not accessible from the code in other assemblies. Let's go to Visual Studio and understand how the internal keyword will work in C#. First of all, let's understand what is an assembly. Assembly is the final product that we'll receive once the project is built. So if I go to build option and select build solution, it will take our code, compile it and generate some output with that. So whatever output is generated for that code will be called as assembly. If you can see here, we have one build succeeded. If you want to see what is the output is generated from our code, we can select open folder in File Explorer. This will open up the folder. And if you go to the bin folder, bin stand for binary. If you open that and go to debug folder and go to the .NET folder, you will see demo_string.dll. This is nothing but an assembly. So all the class files, all the interfaces and all the code which we have written in C# in that particular project is built into this .dll file. This DLL file is called as assembly. If we want to have two assembly, we have to have two different projects in our solution. So let's create a new project for this demo. I will select the add option and I will select the new project. And this time I will search for a class library project. So the class library project is showing up here. I will select that and click on next. I will give some name to my class library project. Let's say demo class library and I will click on next. I will keep the version as .NET 6.0 and I will click on create. This will basically create a demo class library for us. Okay, so it has this class name. Let's change this class name to class library 1. Okay, and if I right click on it and click on build option, it will again build this class library and it will give us the output that is nothing but .dll file. You can see here a .dll file is created at this path. Okay, now let's understand how internal keyword will come into the picture when we are dealing with assemblies. Let's say I have a class here, public class employee, and it has some properties ID and name. And let's build the application again. Okay, we can see build succeeded. Okay, now to use this class library in our demo project, what we need to do, we need to use the assembly of this particular project. Means we have to use the demo class library .dll in this project. So for that, let's click on the dependencies and choose add project reference. Once you select that option, you will see demo class library option here. If you click on that and click on OK, the reference to that project is added in our project. Okay, now what I can do, I can open up any class file in my demo string project and And if I try to create an object of a class that is available in my demo class library, I will be able to do it. Okay. If I go ahead and type here demo class library dot, you can see we have two options, class library 1 and employee, because we were having two classes here, class library 1 and employee. So I am able to access both of those files here. Let's use the employee class here and create an object of employee class. And if you don't want to use this complete or the fully qualified namespace here, you can remove it from here and you can use a using statement for that. You can go here and click on this bulb icon and select use demo class library. So now the demo class library is injected in our class file. Okay, so now I can use my employee object and I can create, or I can initialize the property whatever I want. Okay, this is fine. I am able to access the employee file, or I am able to access the employee class because the employee class is created as public here. Let's say I will mark it as internal. As we have studied before, internal keyword means it will be internal to this assembly. This class will not be available outside this assembly. Okay, let's save everything and build our project one more time. If I build it here, if I go to my demo class, you can see we are getting the error message here. It says employee is inaccessible due to its protection level. Because we have marked our employee class now as internal, we are not able to access it outside that assembly. But still we have the class library 1 class as public, we will be able to access it. If I try to use it, class library 1, I can easily access it and create objects of that. Okay, so this is the difference between a public and an internal class. Internal class is internal to the assembly in which we have created it. Okay, let's go back to slides now. Let's see this table which has defined all the access levels which we have in C#. So just now we have seen internal. If you see here, internal, if something is marked as internal, that will be available within that class, okay, of same assembly. It will be available in derived class within the same assembly. It will be available in non-derived class also. If you go to the different assembly, meaning if we drive that class in a different assembly, we will not be able to access it. And in non-derived class also, we will not be able to access it, because the access level for that is internal. That's why we are able to access it within that assembly. Now let's understand the fifth access modifier, that is protected internal. It was introduced in C# version 6. It will work like this. If we have defined any member as protected internal, it means it will be available within that assembly and it will be available in other assemblies also, but only if they have derived that class. If you see this table here, for protected internal, it is available within that class. It is available in derived class within the same assembly. It is available in non-derived class also, but within the same assembly. And it will be available in different assembly also, but condition is that that class has to drive that class. Okay. Now let's go to Visual Studio and understand this with an example. For now, let's change this class here to public. Okay, and let's have a field here protected internal integer age. Okay, so this class now has two properties and one class field, that is integer age, but I have marked this field as protected internal. Okay, so let's try to access it within this same class. So if I have a method here, public void m, I can access age and I can set it whatever I want. Okay. So it is available within the same class. Let's try to access it in a different class. Let's say we have a class public class C1, and this will, and create a method here, public void m2. And now let's create an object of employee class. Employee e equal to new employee, and e dot, you can see here we have the access to underscore age field here. I can set it to whatever I want. So this proves we have access to protected internal field outside the class also, even if the class is not inheriting that. Now let's see one example where the class is inheriting it. So I will create a class public class C2, and this time I will inherit the employee class. And let's create a method here, m3, and if I type underscore here, I can see age here, and I can set age whatever I want, right? And similarly, I can use the base keyword also, and I can see I have the access to underscore age here. So this proves if something is marked as protected internal, it will be available within that class. Outside that class, even if we are not inheriting employee class, and it will be available to other classes when we are inheriting it. So this is our protected internal. But what will happen if we go to a different assembly? So let's go to our demo class. Let's remove this code and create an object of employee class. Okay. If you hover over here, you can see this employee class is coming from demo class library project. So we are accessing this file, or we are accessing this class from a different assembly. And if I say employee dot, you can see I have access to name property, I have access to ID property, but I don't have access to age field because age is marked as protected internal. It will not be available to other classes in different assembly if they are not inheriting it. That's why when I put dot here, I don't see the age field. If I try to type it underscore age here and try to assign some value here, I will get the compilation error. And if you read the error message here, it will say age is inaccessible due to its protection level. Okay, but if I create a class, let's say C4, and I will inherit the employee class, and let's create a method in it. Okay, and if I try to say base dot, you can see I have the option to use underscore age here. I can type underscore age and set it to whatever I want. So that is the difference. If I am not inheriting that class, I will not be able to access it. And if I have inherited that class, I will be able to access it. So guys, this is our protected internal access modifier. It is available everywhere except when we are in different assembly and we are not driving that class. Okay, now let's understand the last one, which is private protected. Let's go back to Visual Studio and understand this. And let's create a class field and mark it as private protected string underscore last name. Okay, so I have created a class field last name and I have marked it as private protected. So if we look at this table, it will be available within this class, right? So if I try to access it, let's create a method public void and I can say last name equal to text. So I can access it within this same class, and it will be available in the derived classes also. So let's create another class, public class employee2, and let's inherit the employee class and create a method within this. Let's call it m2, and now I can say base dot underscore last name. I can access the last name and set it to whatever I want. So I can access the last name because it is marked as private protected and I am inheriting this class. But what will happen if I don't inherit this class? Let's remove this inheritance and let's try to create an object of employee class, employee equal to new employee. And if I say e dot, I have the access to name, ID, and if you see, I don't have option to use last name. If I try to type the last name and try to change it, I will get the compilation error. Again, we will receive it is inaccessible due to its protection level. Right? So this is how private protected will work. If you see this slide here, it is available only within that class and outside that class only if that class is driving the class which has that member. And let's try to see if it will work in different assemblies or not. So if I go to a different assembly, meaning our demo class, and let's remove this code for now. And if I say employee dot, if you see, we don't have option of last name. And even if I have a class that is inheriting employee class, right? And let's create a method. You can see we don't have option of using underscore last name here. And even if we try to use the base keyword, base dot, you can see we don't have an option to use underscore last name. And if I try to type it out, you will see the compilation error, last name is not accessible due to its protection level. Because we are in different assembly, we will not be able to access it even if we have derived that class. So this is how private protected access modifier will work. So this was private protected access modifier. It was introduced in C# 7.2 and it offers a more restricted access control compared to protected or protected internal. Okay. And as we have seen, it is available within that class itself and it is available to the derived classes within the same assembly. Let's try to see what is difference between a protected and a private protected. If you notice here in this class, we have inherited the employee class, but still we are not able to access this last name property because it is marked as private protected. But let's suppose it is marked as only protected. Then what will happen? If it is marked as protected, then it will be available in the other assemblies also. If I try to access it in a different assembly, I will be able to do it. If I say base dot underscore last name here, you can see I'm able to access it. So this is the difference between protected and private protected. And that's it for this video, guys. In the next video, we will learn about attributes.